The SpaceX Super Heavy Starship will now be made of stainless steel after the company revised the design of the ship. However, the modifications to the design are more involved than simply substituting stainless steel for carbon fiber or aluminum in the construction. In the majority of the rocket, SpaceX will not require the use of upgraded Pica-x ceramic heat shields. According to Elon Musk, the temperature during re-entry only needs to be reduced by 300 degrees in order for active cooling with super cold fuel to be effective. The 310S stainless steel that SpaceX will use has an endurance level that allows it to resist temperatures of up to 1,450 Kelvin repeatedly. Elon Musk and SpaceX have a challenge ahead of them in making the materials, design, and technology work. If they are successful in employing stainless steel, they will drastically reduce the amount of time needed for development. Working with a few layers of stainless steel is more simple and quicker than working with dozens of layers of carbon fiber. If SpaceX is successful in using this material in design, they will see another acceleration in the rate of their product development in comparison to other competitors. Many people continue to have doubts about Elon Musk and SpaceX. With the various Falcon 9 versions and the Falcon Heavy, SpaceX has established itself as the company with the best track record for building and launching new rockets. I am going to proceed under the assumption that SpaceX possesses the data, simulations, and physical testing necessary to justify the design choices that are currently being made. Both SpaceX and Elon Musk are not without their flaws. They just let the Star Hopper get destroyed in gusts of up to 50 miles per hour, which will result in repairs taking several weeks. However, throughout the past 14 years, neither United Launch Alliance nor Blue Origin have sent any newly developed rockets into space. United Launch Alliance, or ULA, has successfully launched a variety of older rockets. Blue Origin has conducted rockets that did not reach orbit. About 80% of SpaceX Starship will never reach a temperature high enough to need the use of heat shield. The active cooling system that SpaceX is currently developing will only be necessary for 20% of the ship. Not long after Elon Musk confirmed the plans to add 3 more Raptor engines to Starship and stretch the upper stage's propellant tanks, the CEO of SpaceX has confirmed one of several smaller design changes that are planned in the interim. These changes are intended to be implemented in the next few months. On January 3rd, Musk stated that SpaceX is completely moving one of the 2 backup header tanks that Starship utilized to store landing propellant. These tanks are located on the bottom of the spacecraft. A diagram that was scribbled on the side of the future Starship rings revealed further plans to modify the majority of the subsections that SpaceX stacks to build on Starship. This modification is intended to complement an updated design for the nose cone. In conclusion, another modification to the design of the hardware that will eventually be incorporated into the first full-thrust Super Heavy booster was discovered. Musk claims that beginning with Starship 24, which is most likely the next ship SpaceX will finish building, the methane fuel header tank will be moved from the Starship's common dome to its nose cone. This change is expected to take place in the near future. The oxygen header tank of the Starship has always been situated near the very tip of the nose, despite the fact that this is a rather inconvenient location for it to be in. This was done for the sole purpose of moving the center of gravity of the Starship forward. Now, the methane header tank will join it in the nose, with the obvious explanation being a requirement to shift the center of gravity even further forward. It's possible that this change was planned before SpaceX realized the performance benefits of a stretch 9-engine Starship, but it's also possible that it was a preemptive modification meant to counteract the added weight of 3 more Raptor engines and longer tanks. The drawing that was found on the side of a Starship part also revealed several more minor design changes. Musk's confirmation that the methane header tank would be relocated came just a few days after the drawing was discovered. It is not unusual to see hieroglyphics on the starbase since SpaceX engineers and technicians have frequently used the hardware itself as a kind of whiteboard in order to draw up plans and physically comment work that is now being done. This specific drawing was really precise and helpful because it demonstrated very clearly how the Starship's design will evolve beginning with Ship 24. The modifications are not overly complicated. In essence, SpaceX will be attaching an additional ring to several different sections of the Starship. In today's Starships, the tankage and hull of the cylindrical Starship are formed by stacking 6 separate parts. The existing design of the nose cone needs an additional 5 stacked sections in order to be finished. If you count the nose as one of the stack processes, it takes around 7 of them to completely create the fundamental framework of a Starship. With the design changes that have been sketched out on a Starship S-24 ring and an upgraded nose cone that will debut on the same ship, the number of stacks required to fully assemble a nose cone has been reduced from 5 to 2 or 3, while the number of stacks required to fully assemble a Starship has increased to 6, down from 7. The alterations, despite the fact that they are not a major redesign, will significantly simplify and hence potentially speed up the construction of the Starship. This will have additional favorable follow-on impacts on the plumbing, wiring, and heat shield installation. It is entirely unclear what benefit SpaceX is getting from keeping a given ship or booster section the same height while adding more smaller rings to it, which is a process that will inherently increase the complexity and amount of work that is required to complete that section. This is in stark contrast to all of the other changes that have been described. In any case, it is abundantly evident that SpaceX is currently in the middle of a large phase of design revision that may result in Ship 24 and Booster 7 making their premiere with a broad variety of enhancements and design changes in just a few months. The most recent rendering of SpaceX's Starship vehicle incorporates many of the modifications that Elon Musk has been discussing in recent statements. On SpaceX's website, you may view an older version of this render that was created before these alterations. The render has undergone a number of significant revisions. At the base of the Super Heavy booster, there is no longer the combination of landing legs and flaps that were previously there. Because the booster will now be caught by the launch tower rather than falling on legs, they are no longer necessary. The booster also has rectangular grid fins that are set in place, as opposed to folding grid fins like the one shown in the previous render. The revised rendering of the Starship vehicle shows that the flaps are a little bit smaller, and the aerodynamic cowling that is located in front of the flaps has been modified to ensure that it is optimized for re-entry. The windows on the Starship have been made smaller and have less curves while also being moved further away from the front of the ship. The most recent render also appears to more accurately depict the thermal protection. The thermal protection tile on the windward side of the flaps, which is black, is no longer completely covering that side. You shouldn't put too much stock on the correctness of the render. It is crucial to bear in mind that these are still merely the artist's renders, even though the updated render appears to more properly match the current design intentions for Starship. The Starship's layout has been subject to frequent revisions, and we should anticipate many more of these in the future. This graphic does not depict the movement and location of the flap towards the windward side of the Starship. We didn't find out until late last month that the flaps would be moved, thus it's possible that the change will take some time to be executed. By moving the flaps, the Starship will be able to approach with its nose further forward, which will shelter the Raptor engines from the plasma generated during re-entry. Because of the higher angle of attack, it is possible that they will require the thermal protection tiles to reach slightly further over the windward side of the vehicle. Despite this, it is really exciting to see this new render of what will soon be the largest rocket that has ever been launched into space. Thanks for watching this video. Please make sure to hit like and then subscribe to this channel for more information.